We begin the topic of counting and the binomial expansion. Lesson 1, the product principle. So the product principle is kind of the key that holds all of this stuff together. It's a very simple concept, but it's extremely important. And just a reminder in case you forgot what the word product means, 15 is the product of 5 and 3. Because 5 times 3 equals 15. So product basically means times. So just another example, AB is a product. It is the product of A and B. And we have our warm-up question here. It says, I own a total of 5 different shirts and 3 different pants. Don't know if you guys noticed this. How many different combinations of shirts and pants can I wear? So how many different combinations of clothes can I wear? I promise you I own more than 5 shirts and more than 3 pants. So I was just joking. But yeah, what's the answer? If you said 15, you are indeed correct. The answer is 15. And let's talk about why that is. And in order to explain why, I'm going to introduce you to very, very important words in this topic. For each. For each. For each of the 5 shirts, there are 3 different pants. There are 3 different pants I can wear. If you want, you can think of it as 2 different positions. So this position here is going to be the shirt, and this position here is going to be the pants. Now, I have to choose a shirt, and I have to choose a pair of pants. So my choices for the shirts, I've got 1, 2, 3, 4, 5 of them. I've got 5 choices for the shirts. And then for each of these 5 shirts, so like for example, if I picked this shirt here, I can still pick any of these 3 pants. So for each of these 5 shirts, I have 3 pairs of pants. That gives me a total of 5 times 3 shirt and pants combinations. And so I have 5 times 3 equals 15 combinations of shirts and pants. Combinations is also a very important word. The root word of combinations is, of course, combine. And to combine means put together. So in how many different ways can I put a shirt and a pants pair together? Well, there must be 15 of them, because for each of the 5 shirts, I have 3 pants. And so in a way, you can also think of for each as kind of, in this unit, is kind of a multiplication. So for each of the A's, I have this many B's. That's going to give me a total of however many A's times however many B's combinations. Just another real quick example. Suppose I have some cats. I've got 10 cats and 5 dogs. If I want to make a cat-dog combination, so if I want to make a cat-dog pair, then for each of the 10 cats, there are 5 dogs. So that gives me 10 times 5 equals 50 cat-dog combinations. Okay, our lesson objectives. By the end of this lesson, students will be able to use the product principle in various counting situations. And you can probably guess what the product principle is. Remember, product means times, and it basically goes like this. For each of, I don't know, let's say m x's, there are n y's, then we have m times n x, y combinations. That's how I would describe the product principle. Our key vocabulary for this lesson: the product principle, for each, extremely important, and whenever you think of the word for each, you should think of multiply. Sorry, I should say the words for each. There are two words there. But whenever you hear that phrase, you should think of multiply. And what is essentially the product principle itself. For each of m x's, we have n y's, and so that means we have m times n xy combinations in total. And we have path, pathway, journey. So a path is like a direction that you can travel in, or a way that you can travel.